melt it into water. Now, ice, when you change it into, melt it into water, what do? We heat it. We heat it. Now, water, you change back into ice. What do? We cool it. So when we reverse the condition, the change also gets reversed. You get back the original substance. When you heat ice, it changes into water, and when you cool water, it changes into ice. So the change can be reversed by reversing the condition, and the change is temporary. It is not a permanent change. No new substance is formed. Similarly here, when you change ice into water, chemically it is the same. What is the formula of water? As you all know, chemically it is H2O. Ice, chemically also it is H2O. There is only the change in the physical state. So there is no change chemically, it will remain the same. So in any physical change, there is no alteration in the substance chemically. The physical state may change, color may change, the shape may change. Let me talk about the shape now. When it comes to the shape, let me talk about, like for example, when you press a rubber ball, it will change the shape. By using a force, it will change the shape. But now you release the force, what happens? It comes back to the original shape. So there may be a change in the shape, and if you reverse the condition, the change will also get reversed. So again, the point number 3 says there is no change in the chemical composition of the original substance. Chemically, it remains unaltered. There may or may not be change in the physical properties such as state, shape, size, color, and so on. And no significant change in energy is involved. Now, so there is no change in the energy. We may reverse the condition over here, but there will not be any change in the energy which is involved. Next is chemical change. Now, when we talk about before we deal with chemical change, let us go through some of the examples of physical changes. Let's go through the examples. Some of the examples of physical changes is now number 1, melting of wax. When the wax melts, it changes into liquid wax. So there is change physically, but chemically it will remain the same. Like melting of ice. Ice melts into water, but chemically it remains the same. Similarly, when wax melts, what happens? Physically it remains the same. There is no alteration in the wax chemically. Number 2, magnetization of iron. Now, when we talk about magnetization of iron is you can magnetize it at home also. You get a permanent magnet. Suppose this is the permanent magnet and this is the piece of iron. You can easily magnetize this piece of iron. We can change this piece of iron into magnet. You either take a north pole or the south pole. Okay, whichever pole you take, it's your wish. So you just have to rub it. You just have to rub it in one direction slowly. You keep on rubbing it for quite some time. This piece of iron becomes a magnet. So is there any change chemically? No. It is still a piece of iron, but only the physical property changes. It will start attracting iron nails or iron substances. Okay, so there is no change chemically, it is just a physical change. So magnetization of iron is a physical change. Number 2, sublimation of iodine. So when we heat iodine, it changes into vapors of iodine. When we heat it, iodine changes into its vapors. Now when you cool the vapors of that iodine, we get back the iodine in the crystalline form. So the sublimation of iodine is a physical change. Now next one is tearing of paper. So when you tear a piece of paper, it is a physical change because it may not be reversible, but the change may be permanent. But chemically, when we see it, there is no change in the chemical structure of the paper. Only physically it may be different. Next is precipitation in the form of rain and snow. You know, the snow or rain. When it rains, it is the precipitation, means the water vapor is condensed back into liquid, into water. That's all. So that is known as precipitation. So precipitation is a chemical, physical change. Breaking a piece of chalk, like the way I break the piece of chalk. Will the chalk turn into something new? No. So it's a physical change. And stretching of rubber band, you know, isn't it? So when you stretch a rubber band, there is change in the shape, but chemically, no new substance is formed. So basically, when we talk about the physical change, a physical change is a change in which no new substance is formed. Next, we talk about chemical change now. Okay, so chemical change is a change in which new substances are formed. That means there is an alteration in the substance chemically. So totally new substance, one or more new substance will be formed in a chemical change. For example, when you burn a piece of paper, it turns into ash. It turns into ash. A totally new substance will be formed. Or let's say burning of candle. Burning of candle is also a chemical change. In fact, burning anything, burning of fuel, burning of paper, burning of wood, burning anything, combustion itself is a chemical change. Now, before we talk about the different examples of chemical change, I want to discuss about the characteristics of a chemical change. So it's on page number 14. The following are the characteristics of a chemical change. Number one or more new substance will be formed which has a different composition compared to the original substance. That means totally new substance will be formed. Number two, the change is permanent and irreversible. You cannot reverse it back. Okay, like over here, when we heat in a physical change, when we heat ice, it changes into water. But when you cool it, it reverses back into, we can get back the ice. This is not so in the case of chemical change. The change is irreversible and it is permanent. Number three, an energy change is generally involved in a chemical change. Energy is either absorbed or evolved in a chemical change. Let me talk about some of the examples. A reaction, a chemical reaction in which, since we are talking about a chemical change, we'll talk about a chemical reaction. A chemical reaction in which heat is evolved, heat is produced without external heating, it is known as exothermic reaction. Let me tell you again. A reaction in which, a chemical reaction in which no heat will be produced, in which heat is produced, heat is evolved, it is known as exothermic reaction. It is known as exothermic reaction. For example, respiration, internal respiration. So what happens in the internal respiration is we eat food, right? And the food gets digested. Another story is that the food gets digested and it's absorbed by the blood, and the blood takes the food to different parts of the cells. Okay, the food is there in the cells. Now, you breathe oxygen. Where does the oxygen go? It goes to the lungs, and from the lungs, the blood again takes it to the different types of cells. And within the cells, now what happens is the food and the oxygen will react. The food which is already there and the oxygen that you take in will react with the food, and then energy is released in the form of heat. So that's why we have a fixed body temperature. So that is respiration, internal respiration, where heat is produced, is one of the reactions. And the other simple reaction that we have always seen in the day-to-day life is we get calcium oxide or quicklime. We get calcium oxide or quicklime. If you don't understand that, it is called tuna. Okay, you put water in cold water. You know external heating is needed. You just get in a container. You put calcium oxide or quicklime, and then you add water to it. Now what will happen to it? You will see that the water will start boiling because the heat is produced. So when the calcium oxide or quicklime reacts with water, it produces heat. So it's an exothermic reaction. Now another type of reaction in which heat is absorbed is known as endothermic reaction. So when a chemical change takes place with the absorption of heat energy, then it is known as endothermic reaction. So that's the difference between exothermic reaction and endothermic reaction. So in our chemical reaction in our body also, chemical reaction to take place in our body, we need a suitable temperature. We need a suitable temperature, like the body temperature that we have. So there are numerous chemical reactions that is taking place in your body right now also. Now it takes place in an optimum body temperature. If the body temperature increases, you become sick. Why do you become sick? Because most of the chemical reaction cease to take place. That's why you become sick. So that's why optimum temperature is needed. That means heat is needed for the chemical reaction to take place. So these reaction, which needs heat energy, is known as endothermic reaction. Getting my point? So that's the difference between exothermic and endothermic. Exothermic reaction is the reaction in which heat is evolved, and endothermic reaction is the reaction in which heat is needed or heat is absorbed. Now the last point when we talk about the characteristic of chemical change is the mass of the substance undergoing a chemical change is generally altered. Okay? But however, it may be noted that the total mass of the substance involved in a chemical reaction remains unaltered. It will not change. For example, when we talk about a candle, we have seen a candle burning, isn't it? It's a burning, as I told you, burning anything is a physical or chemical reaction. It's a chemical reaction. So when you burn a candle, you must have seen that the mass of the candle keeps on decreasing, isn't it? But when a candle burns, what are the products? Let me tell you. The products are carbon dioxide and water vapor that you cannot see. You can just see the size or the mass of the candle diminishing. It becomes smaller and smaller and smaller. The size becomes smaller. Yes, the size becomes smaller when you burn the candle. But the book says the mass of the substance remains the same in a chemical change. Let me explain. Now, when you burn a candle, what are the products? Carbon dioxide and water vapor that escapes into the air. But if we manage to trap the carbon dioxide and water vapor, the total mass, you will see that total mass of the candle will remain the same. The actual mass of the candle before burning, and if you trap all the carbon dioxide and water vapor which is formed, along with the tiny bit of candle left, the mass will be the same. Now we talk about different types of chemical change. So we eat food, the food gets digested, a totally new substance will be formed, the food will be broken into simpler substances. So since totally new substances are formed, it is a chemical change. Okay? And the complex food, during the digestion of food, the complex food will be converted into simple and soluble forms so that our body can absorb it and utilize for many other bodily functions. Number 2, the next one is ripening of fruits. Okay, there is a change chemically. You may not, let's say a mango, a raw mango gets ripened after few days. Okay, mango does not turn into something else, but surely its taste will change from sour to sweet. That means there is a chemical change, a totally new substance which is formed inside chemically. So ripening of fruits is a chemical change, even though physically there is no change, but chemically definitely there is a change. So that's why we consider ripening of any fruit is a chemical change. Next, I told you the burning of candle. Not only burning of candle, you burn anything, combustion. Combustion process itself is a chemical change. You burn candle, or you burn fuel, or you burn wood, or you burn your gas at home, the cooking gas at home, whatever. Burning is remember, it's a chemical change. Because when you burn a candle, for example, when you burn a candle, it forms totally new substances, carbon dioxide and water vapor. When you burn your LPG gas at home, also the products will be the same, carbon dioxide and water vapor. You will not see the carbon dioxide, you cannot see water vapor, but they will be produced. A totally new substance will be formed. Rotting of eggs. So when egg rots, you know which gas is inside? Yes, hydrogen sulfide. Yeah, hydrogen sulfide gas is formed in the rotting of eggs. And fermentation. Fermentation means making of the process in which is used in making wine and alcohol, you know, from simple sugars and fruits. So that is fermentation. So fermentation is a chemical change. A totally new substance will be formed. Rusting of iron. So when we talk about rusting of iron, you have seen this is the time when we see the iron rusting. So iron rust is nothing but oxide of iron. So iron will rust in the presence of oxygen and moisture. So when it's a very slow process, of course, it's not a fast process, it's a very, very slow process, but the rusting takes place only in the presence of moisture and oxygen. So iron will turn into its oxide form, iron oxide, rust, slowly, and totally new substance is formed, you know it. So iron turns into iron oxide, that is rust. So it is a chemical change. Why? Even though it's a very slow process, it is a chemical change because a totally new substance is formed. Burning of piece of magnesium. So when the school reopens, I will surely show you the burning of magnesium. So burning magnesium ribbon, it's a metal. Magnesium is a metal which burns easily and which is used in firecrackers and so on, which sparkles. It burns very, very brightly to give you a bright white light, and it turns into. Let me give you the reaction of magnesium burning. Magnesium Mg burns in oxygen to produce a totally new substance, a white ash-like substance called magnesium oxide. So burning anything, as I told you, is a chemical change. So the last topic for today, the differences between physical and chemical change. Okay, physical and chemical change. The last topic, the class is about to be over. The composition of a substance. No new substance will be formed, as you know, in a chemical change. New substance will be formed. Nature of change. Change is temporary and reversible in a physical change, whereas when we talk about the chemical change, it is permanent and irreversible. There is no change in the physical change. There is no change in the mass, in the mass of a substance undergoing a physical change. But in a chemical change, there might be a change in the mass. In a physical change, no significant change in energy is involved, and in a chemical change, there is either evolution of heat or absorption of heat. As we had already dealt about it, the exothermic and endothermic reaction. So in the next class, we talk about the changes involving energy in the physical changes, and then we'll continue with a new chapter. But for today, Thank you so much.